Okay, I am going to correct this for response 2 from the Electrostatics test A. So start out, the first question, we have the circuit here. First question says to calculate the equivalent resistance of the bulbs in parallel. So the bulbs in parallel are right here. And the way to calculate resistance for bulbs in parallel is to put them, use this equation right here, 1 over R. The resistance is equal to the sum of the other resistances, 1 over the resistance. You add them together, and whatever the base is the resistance. So you add 1 over 6 for this one, and 1 over 3. 1 over 3 for this one, and you're going to get 1/2. So you take the 2 from the bottom, and the resistance is 2 ohms. The second, B, calculate the equivalent resistance of the entire resistor configuration. Well, since you know that the bulbs in parallel have a combined resistance of 2, and you know that this one has 3, since the parallel bulbs are technically in series with this one, you just add them together. So 2 plus 3 equals 5 ohms. That's the answer to that one. C, calculate the amount of current that passes through bulb A. What I initially did wrong here was, though, I set up the equation right. V equals IR, so I equals V over R. So you take 9, which is the voltage, which is given to you there, and you put it over 5, which is the which is the resistance of the entire thing. And what I did wrong initially was I put it over 3 because that's the resistance of just that bulb. I now see that I was wrong. You have to do the resistance of the entire circuit. So you put that over that, and you get 1.8 amperes, which is the current that flows through A. Next, calculate the power dissipated by bulb A. The equation I used was power is equal to the current multiplied by the change in volts. So P is equal to 1.8, which is the current that I found in the last one. And then you get 5.4 for the voltage after the drop over bulb A. And you multiply those together, and you get 9.72 watts for the power dissipated. Which light bulb is the brightest? Justify your answer. Bulb A, because it's using 9.72 watts, and that is by far the most power being used by any of the bulbs, which would mean that it is burning the brightest of the other bulbs in the circuit. Okay, this part, if you were to open the switch, which is located right here in the circuit, is what would happen to each bulb, to the brightness of each bulb. So for bulb A, the brightness of bulb A, right here, right there, the brightness would decrease, because if you were to open that, then the resistance of the entire thing, of the entire circuit, would increase to 8 ohms, because you just have the 2 in series, and it'd be a 6 and a 3 ohm resistor, which would equal, 9 ohms then, and that's an increase, which means that the brightness would consequently decrease. Bulb B, the brightness increases, and the reason for that is because although the current of the entire circuit is decreasing, it's still an increase for this bulb because it was previously in parallel, so it was getting less of a current because it was splitting it with the other, it was splitting the current that could potentially go through it with the other bulb that it was in parallel with. Bulb C, the brightness decreases because once you take the switch off, it's only connected to the circuit by one side, and unless it's connected on both sides, no current is going to flow through it at all. So it will not only decrease, it'll completely go off. It's cut off from the circuit. And that's really it. Really what I learned, or what I did wrong initially, was I used the equations wrong. I didn't take into account the entire circuit when I should have. I just focused on the one bulb. I didn't really understand how to put the equations together, how to use them in harmony together exactly. I didn't know how to combine them and use them together. That's about it.